show that log base 2 of 11 equals log 11 over log 2, and hence find log base 2 11. We'll come to it in a minute, but hence means use the result to do this. So what it doesn't mean is find the answer in another way. That would not get you any marks. So if we think about log 2 11, we're going to call it x. So let log base 2 of 11 equal x. So we're going to call that thing x. Now, the way to undo a log is to think about the base, which is 2. So you raise that base to the power of both sides. So we are going to raise the base 2 to power of both sides. Okay, so on the left hand side we're going to have 2 to the power log base 2 11. On the right hand side we're going to have 2 to the power x. So 2 to the log base 2 11 equals 2 to the x. Now if you're getting good at these logs, you've done quite a lot of them and you're feeling a lot more comfortable, you probably wouldn't need to write 2 to the log base 2 11. You would just write 11. I'm trying to drum this point home because I really need it to get to you. So log base 2 11 is the power that you must raise 2 to reach 11. So if I then raise 2 to the power that I need to raise 2 to reach 11, then I must reach 11. So this whole term is 11. So 11 equals 2 to the power x. Now this is where the log 10s come in. So when it says log 11 over log 2, well that's base 10, that's the common log. Remember, if a base isn't written, then it is base 10. So now what we're going to do is take logs of both sides. And that just means you write log 11 equals log 2 to the x. Log 11 equals log of 2 to the x. Log left equals log right. Now what I'm going to do is use the third law. This is why logs are so useful. They're really good for solving equations when you've got your unknown in the power. Because of this third law of logs, you can move the power as a multiplier, and it makes it so much easier to find. That's one of the major applications of logs, is to solve equations where the unknown is in the power. So using the third law, log 11 equals x log 2. So now if we just solve for x, we're going to divide both sides by log 2. So that would say log 11 over log 2 equals x. And remember what x was. X right from the start was log base 2 11. So now I can just replace this x with log base 2 11. So that now shows us that log base 2 of 11 equals log 11 over log 2. Okay, so we've shown that to the big case. Now what we're going to do is the second bit. So it says now hence find log base 2 11. Now on your calculators they do, because they're modern calculators, you could just type in log base 2 11 anyway, but for years and years and years you only had log base 10, which is this, and log base e, which you'll come to in a year or two's time. Actually, if you go back even further, they had to look in a book to get the logs, but we don't have to worry about that. So what we have to do now, so log base 2 11 equals, well, I just need to do log 11 over log 2 on the calculator. I just need to do log 11 over log 2. That is 3.46. I haven't been asked for a specific amount of accuracy, so we'll give it to 3 significant figures. Remember, the way you do that, you find the third significant figure. So 1, 2, 3, it's the 5. You look next to the 5, that's a 9. The 9 will make the 5 round up. If you're not comfortable with your rounding, write the long number down, because then you're going to lose less marks if you round it wrong. 3 significant figures. I won't show you where the how to directly put log base 211 in, because it's not going to help you in your exams.